Welcome to this submodule of the Copernicus Land Monitoring Service, which presents a concrete application of one of the global Copernicus Land Monitoring products by a user in Spain, which has been using a certain biogeophysical variable to calculate soil erosion. And this is an application that has really been undertaken and has brought significant advantages to the user. That's why I'm going to present it here now. As a background, one can say that soil erosion is a common phenomenon and a common problem appearing in the Mediterranean area, specifically in Spain. And in Andalusia, there's a lot of soil erosion, typically at times when there are bare soils. So in winter, when no agricultural activity is taking place and when the raining is starting, and specifically after and before the growing season. So that can cause relatively high levels of soil erosion because there's no resistance to the surface runoff and the taking away the soil with it. Therefore, specifically to have information on the spatial distribution of these soil erosions occurring and on the susceptibility of the soil to soil erosion is a very important thing to basically measure and to counteract the soil erosion. In this case, there has been a user, the Junta de Andalucía, which has an environmental information network called REDIUM. It has the mandate to monitor soil erosion and is doing that since many years. It's using a model based on the universal soil loss equation, which is used to calculate in a distributed manner where these areas do occur. Now, what has been found is that the Copernicus Land Global Product F cover, which is the fractional vegetation cover, can be used to substitute part of that sophisticated but also complicated calculation process, providing significant advantages to the user. So that product F cover is directly fed into the model and is also available on a regular 10-day interval. So it can be used also to update the situation on very frequent and regular terms. Instead of doing that calculation based on the universal soil loss equation just one time or in irregular terms, this has proven relatively or rather efficient, fast and cost effective. So in terms of input data that have been used for that, one has to say that in Spain the situation is such that typically Copernicus data and other public open source data are made available through a national data infrastructure, SDI, which organizes these external data sets and converts them and documents them also in a Spanish manner so that Spanish national users who are probably not so familiar with English or other languages can directly use them in the system. So these services are then also transferred into that system and made available to users that way. So here you can see an example. On the left-hand side, you have a screenshot from the Copernicus portal, Global Component Products, and on the right-hand side you see the transfer, how this is organized in the Plan Nacional de Teledetección, which provides these data then in a Spanish fashion. First step to make use of these data is to, of course, search and select the data, both in terms of the spatial extent and also the temporal extent, either on the Copernicus website or on the Spanish portal, and make use of that. As a comparison, you can see here, this is how traditionally the components of the universal soil loss equation were calculated by the REDIUM, and there's also a link given which you may want to access, where the description is given how that system has been implemented in a traditional way. Now, using that F-cover product helps substitute a complicated calculation of a contributing factor to that soil loss equation, the so-called factor C, which I'll just show in a second. So this shows the processing chain that has been traditionally used to calculate the soil erosion, starting from optical satellite imagery, so you need a time series for doing that, then calculating vegetation-based indices like the Normalized Difference Vegetation Index, NDVI, and then using parameterizations for different land cover types and categories being applied to these data, resulting in an input factor that's called factor C, which is one constituent of the universal soil loss equation, like other factors like the erodibility of a certain underground material, the steepness of the surface, and all kinds of surface properties, which are combined in that calculation model into a soil erosion risk, basically. Now that relatively complex scenario has been replaced by introducing directly the global components F-cover product, which you see here, introduced exactly on that point where formerly the factor C, which represents basically also a cover percentage of the surface, has been used before. So all these steps which have been crisscrossed here can be skipped and the process can be significantly simplified. So in terms of outcome, the Radium uses operationally on a regular basis now these global Copernicus land products and publishes their results based on this innovative and new products, which is a good example of direct use of such kind of Copernicus products. If you zoom in more detail, you see that the resulting soil erosion risks are really provided in a spatially very detailed fashion, and that helps, of course, local authorities to take measures against these threats in a regional scale. Thanks for your attention.